Hey guys, good morning. Yeah, I just found there's quite a few steps involved in getting getting the class going in terms of setting up the Zoom. So many links to click on. Anyway, so today is the day. Is today the day of the midterm? Yeah. Okay. All right. Actually, for all my sections, so it's going to be fun to see what the 2C guys are up to. Um, so we'll keep it, today's class, relatively free form. Well, like every single class, I guess. I was thinking, here's an idea, right? Let's take the program that, who coded last class? I forget. Yan, where's Yan? Oh, there he is. Okay, yeah. So we can take the program that Yan wrote, finished up, right? We don't want to get into that situation where we picked up you remember last class, Jacqueline had coded more and then we picked up an earlier version of the code, and then we had to recode all of that. You remember? I don't know, Jan. Okay, so anyway, pick up the most recent version, which I believe we managed to run with Turkey's, pack, right? Yes, you created a pack and we managed to run it. So we'll just play around today, right? So I have a couple of things that ideas that we can use to add features, right? Bells and whistles to that program. So I'm thinking, well, one thing we can do is add some visual effects so that the sentence doesn't come on immediately. We inject something to make it more interesting, right? And I was thinking the way we can do that is to have someone else develop the visual effect, right, in a separate file of their own, with their own main to test it. And they share that function with, in a manner of speaking, with yen-use code, right? And then we'll link yen-use code with this function. And then, so when you run, Yan's program with Turkey's pack, well, hopefully not Turkey's pack, right? Someone else's, because Turkey's was very generic. It had all kinds of nouns and all kinds of verbs, right? So if someone can create a pack that is tailor-made to a particular genre, then we can run Jens program with that person's pack using this third person's visualization. So there's 3 people involved already in the creation of this fun little program, right? And if any of you are interested or have some knowledge, you don't have to have any knowledge of HTML, CSS, and JavaScript really, because with the C++ at this point, you can easily translate everything you do into JavaScript, right? Just a few minor changes here and there, right? And you'll know what kind of changes to make too. So, and HTML is very easy. I can show you how to turn this into a web game, right? And then you can take your own time after that over the summer, maybe, to add bells and whistles and visual effects and backgrounds and, kind of customize the page as much as you want. But the core elements of it, we can just build. It'll just take a couple of hours, or maybe 1 hour. 1 hour of, if you've got the C version working, the C++ version working, it's probably 1 hour of time, right? Just porting it into JavaScript, and then you can, and especially if you have an Amazon or some cloud account, you just host it in a public bucket, right? So that anyone can click on it, and you won't even have to pay server charges. I think I mentioned it before to some other students also in a previous class, maybe. Yeah, you don't even have to pay for a server, right? You just host it in a bucket. It's like a disk, like Dropbox, right? You have host it in a Dropbox, and then people can click on it and immediately play the game in their browser. So yeah, we can do all those things. Actually, that's interesting, isn't it? Does Dropbox allow you to store static HTML pages? Store and basically publicly accessible static, because there's no cost to them, right? Essentially, they could basically provide the equivalent of something like GeoCities. I don't know, maybe there's security issues involved, but they could do. No, Amazon is doing that with S3 buckets, and every cloud provider is doing that. So I don't know why. All right, anyway, so that's my idea. We can continue talking for another 5 minutes, right? We'll start class at 8:15. And in the meanwhile, You guys should feel free to talk amongst yourself or think up new ideas, right? Think up new ideas to implement. My idea is that we're going to implement some visualization in the code, right? Oh, the other thing we can use today's class for is basically now this program has actually grown, right? It's not like 10 lines or 15 lines, it's like 100 lines now. So there may be portions in the code that you don't understand, which are actually important for your midterm, right? So you may say, what's an ampersand doing there, right? So why is the vector has an ampersand? Why does it have an ampersand before it? What's the effect if you don't have an ampersand? So those kinds of questions are important to know because they're concept questions. And also they're important because these are not part of other languages, right? So maybe you learn the 1A track or 3A track, right? Learn Java or Python or some other language, right? You'll never come across a situation where this particular feature is available, where you can actually pass a value by either reference or, right? So most languages have some other way of doing these things. And this is a very nice and powerful feature that you can only encounter in C++. So if you don't understand that completely, that's again something that we can talk about today. So think of things that you want to add to this program, right? So my idea is visualization. Maybe someone else says, I want another kind of feature. Maybe it's going to, when it's loading, maybe a simple feature, right? Every time it loads this pack, it'll say, I am now loading pack, and then the name of the pack. And then it'll say how many verbs, how many things it loaded from each of these files. These things, these interesting things you can, maybe that's one thing you may wish to add. Someone else might say, I want to change the interaction of the game, a drum roll and things like that. Not audio drum roll, but some kind of, well, basically the scope is endless. So you guys should feel free to think about these things and call out. And this is something I'd like to implement, right? And then we'll just take that idea and run with it. So today, all we're going to do is basically take an existing program that we already have and play with it. And it doesn't matter if we break it, because we know we have a working version of it somewhere, right? So we have a working version of it, so you can take it, play with it, change things, and see if it works. Doesn't work, okay, it reverts. And so that's a great opportunity. I think we learn a lot just by breaking things, not in the bad way, but learn a lot by taking things apart, taking things apart, right? Meaning that if you take things apart, you're essentially breaking them, but you're breaking them in a reversible way, right? So breaking things irreversibly is bad, but breaking things reversibly is good, right? Because you break it, you know why it doesn't work, so you can put it back, you reverse the change, right? So you can do millions and millions of those changes in your life, and then you can figure out the right way to do things, right? So and I think where most programmers actually and I don't think it's go the wrong way, but have face hardship. Face hardship is that it's hard to tell the difference between. Well, I don't think it's hard, but it's something that can be easily trained, right? Easily trained. So easily learned is to tell the difference between a thing that you can break, but it's reversible, and a thing that you can break that is not reversible. Right, and so many programmers are reluctant to make changes in their code, or in code they download, or in code they're playing with, right? So they don't want to change things and run the program because they don't know if that changes, if they can put it back. If they put it back, what happens if I break something and I can't put it back? Then we're totally screwed. And I think that is what prevents us. That inculcates a sense of fear that prevents us from testing things and saying, what if I break it? What if I break it? And that's basically an invisible shackle, right? It's invisible force that's holding us back from doing many things in our life, because we're fearful that we can't get back to a state where everything was okay. So I think the important thing is to basically get to a state where we're okay, right? So we'll get to a program that works fine, right? You can tell there's no bugs, and so we have that as our golden standard. Then from there, because if nothing else works, so yeah, I think that's a ticket, right? So where we need to get to be is to a place where we're happy that it works, right? And we're willing to take risks and do more things, and we don't care if those other things work, right? We don't care if these things work, because even if they don't work, I'm still happy, right? Okay, you still got working code, right? So I'm going to take all these risks, because even if those risks don't work out, I'm still happy person, right? So, but if you don't have this, right, you're never ever going to take a risk. Because if something breaks, you're still not happy, right? So, and yeah, I don't know if it's explaining it right, but having a working solid program in your kitty, right? So somewhere locked up, I think helps a great deal. Because I was thinking yesterday, because I was guiding a couple of you through some difficulties, right? Some justified difficulties, and I realized, and then after that I thought, why are students still fearful to try things, right? Because there's no reason. In those days, of course, CPU cycles were expensive, and computing. Well, yeah, there's nothing to be afraid of. Yeah, and there's a lot of hardware safeguards built into your program that even if you use C++, right, you can't melt your screen down. Right, so it's technically possible, right? Because with C++ you get access to drivers and everything. You can change the clock rate, overdrive your CPU. You can do all kinds of crazy things. But in order to do that, even in C++, you need to bypass some safety standards and crazy things you have to look up documentation for and follow, obscure rules to get, and it intentionally made hard because these things could damage you, right? So, and this is because lots of people have done these things and been burned, right? They did something and they got really burned badly, and so they went back and then they survived, right? So if they got burned badly and they died, so you never know. Right? So what we want are brave programmers, okay, who got bitten really, really, really badly, right, by their programs, but the bites were not poisonous and they didn't kill them, right? So they recovered and they came back to the good world and said, okay, well, all right, you guys, you know what? I tried all these crazy things out there, but they all killed me. I came close to death, but fortunately I didn't die. I came back, so I'm going to make these things really hard for you guys to do, right? So you guys to do so that it's still possible. You know how to do it, but it's going to be hard. So that's why all these old languages are really good to try, because these programmers have built lots of safeguards, having gone through the difficult parts themselves and saving you, right? So they've taken on your suffering essentially, right? Because if they hadn't suffered, you're going to suffer. So they said, I've done the suffering for you. Here it is. You don't have to suffer. Just just watch what I did, okay, and do something similar, and you'll be okay. And so all of that's intentional. And we should feel free to knock ourselves out, I mean, so these days you can't do much damage to most computers. Everything has been taken care of, and most things, right? And yeah, in fact, you need to be really, really good in order to melt your computer down. If you're able to melt your computer down, you would know not to, right? So that's the delicate balance that's been struck, right, within programming, is that you need to say that the safeguards that have been built into mundane everyday programming these days are so good that's why we have all these rules, right? All these languages, we have all these rules. The rules are there to make it so that it's by the time you learn the rules, all the rules, you also know how to melt your system down, destroy everything, right? Because you don't, essentially, let's say, even if you did want to destroy everything, you won't know how to destroy everything until you've learned all the rules, by which time you can destroy everything, but you don't want to, right? So that's I think the survival of the best rules, right? Eventually that's what everything is filtered down to, is that a set of rules that you will learn and you will master yourself, but you will not be able to get what you want until you learn all the rules, right? And then you know what you want to do, but you don't want to do it, right? So I think that's the best place to be, right? And yeah, so we can do all that, right? So we'll take this program. What a long-winded explanation to keep the airways occupied, right? So until yeah, you can start. I was planning to talk until 8:15. It's 3 minutes past, so we can start if you guys want. So here's what I'm thinking, right? Easy visualization. Actually, if someone else has another idea, we can do that too, right? So feel free. And by the way, I've sent some of you email. If you have email from me, please reply, okay? Because I need to know whether you've read the email, because I don't know if the channel is working at all, right? So if you haven't received email from me, that's fine. But if you have received email, please do reply. So I need to know. Because Because if there's certain things that I want to communicate to you regarding your homework or exams or things that you've missed, that's how I do it. Okay. Yeah, or even Canvas. Even if I communicate to you in Canvas, it goes through and you reach it, you get it via email. But the reason I prefer email is increasingly is because I came to know only a couple of quarters ago that most of your Canvas configuration settings by default don't notify me via email, right? So you get a lot of messages in Canvas, but you don't get email notification that you got messages waiting to be read. So then I ask students, I sent you so many messages on Canvas. Why didn't you, respond? I say, no, I didn't even see the messages, right? And then they go to notification settings, and there's a setting that says, send me an email every time there's a Canvas message, right? And that's not on by default. So what's the point then? Why would I ever send you a Canvas message, right? So these are things that you have to think of when you're a developer, right? Developing your own product, is that if you ever create a feature like that and it's not on by default, it'll very quickly die. Because people will stop using that feature, because as it is, if I send you email, I only have an 80% chance that you'll read it, right? So that's 0.8 probability already. And then add another 0.5% probability that, Canvas is going to forward that email onto you. So we're actually looking at 0.8 times 0.5, that's 0.4. That's less than a coin toss, right? Less than equal odds that you'll even read the email. So I would not send it ever through Canvas if that's the case, right? So please, so if you have email, I'm actually picking up your email addresses from your photo portal account, not even through Canvas, right? So if you do have email, do reply. All right. So let's say someone else, any of you wants to take the screen. Take the screen. The only condition is you need to have a good connection. Okay, a good connection, a good internet connection. Yeah, and so pick up the screen and also pick up the link that Yen could share. Right? Hey Yen, can you share a link to that code that you wrote last class? You don't have
I show you on Reddit
Yeah,
already.
no, but as it requires a login.
Oh, okay.
Yeah, yes. So change that to be a open to all. All right. So pick up that code, and if anybody else has ideas, let me know, and we'll code it. Otherwise, let's just go ahead and open up a window, look at the code, briefly go over it from top to bottom. I'm not going to do anything, right? So you guys talk each other through the code from the top to the bottom, any of you, right? And make sure you're all reasonably comfortable with the code, and then we'll start. We'll say, okay, that's the code. Now we're kill that code, right? So we'll delete the code. We're going to do a brand new program altogether now, a brand new program, which is just going to do a visualization of some sentence, right? So we'll do that. And then after that, we'll bring this code back in, right? And tie them together, right? And so that is going to be our dance for today, I think. And of course, any other features that you want to implement, we'll give it a shot to. And meanwhile, some of you, it would be nice if you just create some packs, right? So even if you don't have to have like 100 words in each file, right? So if you take the Game of Thrones genre, for example, right? So maybe you only have like 10 nouns, right? 10 nouns, 10 verbs. Because if you think about it, how many of these we have how many? The sentence is like 10 letters long, right? 10 words long, right? So if each word has 10 choices, we're actually looking at 10 to the 10 sentences, 10 to the 10 possible sentences. That's 10 billion sentences, right? So if each of those categories can generate 10 words, obviously it's not 10 words, we only have 3 prepositions and 3 articles, right? So but I'm thinking, the rough order of magnitude is 10 to the 10. So that's a very large number of sentences that you can generate, even if you only have 10 choices for each. So now you can imagine with Turkey's pack from last week, how many possible sentences you can generate, right? So each one has like 10,000, right? So 10,000 to the power of 10. So it's a crazy big number of sentences you can generate. Okay, so someone make these files, right? Just 4 files. I think not even prepositions and prepositions and articles, right? So only nouns, adverbs, verbs, and adjectives. So those 4 files. Just make those 4 files. .txt files. Put them in a folder. Put them in a folder, right? Called by your genre name, right? Zip it up, .zip, and send it, share it. Right, and then we'll just pick up the zip and unzip it and run it with the name, right? And we can have many, and the cool thing is we can have many packs in the same folder, right? In our lucky folder, we can have like 15 different packs, and we can basically say lucky pack 1, lucky pack 7, lucky pack 3, right? Each one will produce a different kind of sentence. Besides, all these things will make it interesting. So yeah, let's basically have fun today, right? Obviously, if you have any questions about the midterm, happy to answer that. If you have any concept questions, I'm happy to answer that. Hey, Chan, you just sent a text message that flashed on the chat, so you can feel free to just interject and talk. Okay, so you have a question?
A general discussion of like vectors and passing by reference.
Okay, I don't even see the chat. Thank you, Mark. Wow. Okay. Oh wow, there's a big discussion going on in chat. All right. Okay, cool. Hey, unfortunately, all of that is not shared on. It's not preserved, right? I don't know. It doesn't go into the recording, and if I didn't see it now, I would never see it, right? I'll just. So we've got to figure out some way of having these discussions in a way that can be preserved for future students too. Right? So you can basically say, hey, Anand, can you give me a sec because there's a question in chat, we want to talk about it. That's fine, right? And then I can just become an audience member and you guys can have the conversation. Exactly that conversation can happen in Zoom, right? Why should I be talking while an interesting conversation is happening?
Yeah, so let's talk about the passing by reference, especially when it comes to the ampersand symbol.
Sure. Mark is going to talk about it. Mark, you're going to talk about it, right? Are you asking me to talk about it, or you're going to talk about it?
I prefer if you discuss it because I can't say.
Yeah, sure. No, I just wasn't sure. I wasn't sure. That's why. Because if you wanted to talk with and have a group discussion, that's fine too. But essentially, what that ampersand means. Okay, can you bring up that code? We'll just look at the code and talk. It's actually easier because then we can just say, hey, that's what this means. That's what this means, right? So can someone bring up that code, the code from last class, and then we'll just look at that code. All right, get to a place where you have that. Yeah, okay, there. That's fine. All right, so Mark has a question, he said, what is that thing? What is that vector of string and then the ampersand back? What does it mean, right? What does it mean that, is that your question, Mark? Do you want us to talk more about that?
Yeah, sure, appreciate it.
All right, so yeah, and the reason this is important is because this is not part of any other language. And if you're a Python programmer, this is actually new to you, right? So ampersand, it has two different meanings, two different but related meanings, right? Two different meanings, but we don't have to for this class and for the midterm. There's only one meaning you need to be concerned about. So if you ever encounter in your readings, in online and so on, because I'm saying this because most of you are going to go on Google, right? What does the ampersand mean in C++? And 50% of the hits will be about this, and 50% of the hits will be, all right, it's an address off operator, right? And you don't know which one to do, and you're going to be so. So this is a very important class because for the midterm, which is today, you don't have to worry about the ampersand having the second meaning, which is address off. If you look at any online reference that says this is the address off operator, just ignore that page for now, okay? Until week 10. Right, week 10 we'll talk about address off and things like that. Okay, so until then, forget about it. So what we need to concern about ourselves with is the ampersand when used in a function signature. Right, that's a function signature. Void, read words. It also happens to be the function declaration and the body and everything is together. But if you look at, can someone highlight? Who's got the screen, by the way? Chandi, can you highlight just the function signature, right? Everything up to the, also the parentheses, I think the parentheses is required. The whole thing, up to void, that is called the function signature, right? The signature says, this is what the function is going to return, okay? What does this function return? And someone tell me, what does it return to the caller, right?
Doesn't return anything.
Sorry, Chris?
Oh, void so it just doesn't return anything. Since it
doesn't return anything. Yes, thank you, Chris. Okay, so void, it doesn't return anything. That's why you see there's no return statement. Well, you can have a return statement, but you can have a return something statement, right? In other places, you'd say return 1, return 2, return 5, right? Or return the result of this function. But void means you can return something, right? You just have to return. Or you don't have any return at all, and the compiler will automatically put a return for you. So it's not like a return is absent, but a compiler will give you a freebie return at that line. Okay, so that is a function signature. that when the ampersand is seen inside of a function signature, it means something different, right? In most of the contexts, in very rare contexts, it's going to return the address of. No. So in a function signature, it's always right. This is the only thing where we need to be concerned with. What ampersand means is that if there is a parameter or a reference value involved here, right? Return value, right? If there's either a return value or a parameter, the ampersand can be anywhere, right? So maybe void, read words, maybe it returns an int. Is everybody following along? Right? Because, right, maybe read words return an int, right? So you have int read words. Yes. Now, suppose it's not returning a copy of the int, but it's got some internal static variable and it's returning a reference to that integer, right? So it's got a variable inside of the function. Usually variables inside of functions will die as soon as the function finishes execution, right? But there is a special kind of variable which you haven't encountered yet, which we'll encounter 2 weeks from now, right? It's called a static variable. So that a static variable is a variable that vivifies, and we've talked about vivification before, right? As a variable that comes into being as soon as a function is invoked, right? And then it dies when the closing brace, the function exits. That's the usual variable. A static variable, on the other hand, right, is always there. It's only visible within the function, but it's always there. So anyway, the reason I brought this up, and I shouldn't really have done that, so let's just rewind there. What it means is that because that variable is always there, you can return a reference to it. You don't have to return a copy. You can return a reference because that reference is always going to be valid because this variable is always alive. Okay, so in that case, it makes sense to put an ampersand even before the read words, the function. That means the function itself is returning a reference. Now, that is closely related to what happens when you have an ampersand before a parameter. So now let's look at vector string ampersand vec, right? What that says is that the ampersand vec means that that vec is not a copy of the parameter. That parameter is not a copy of whatever main has, right? So main called main, right? Main called read words, I assume, right? Some function called read words. Yes or no? You guys have to give me some feedback, okay? I'm going to minimize those code so I can see more of you. Great. Okay. All right. I can see all of you. All right. So yeah, give me some feedback. What was I saying? What was I saying? Tell me if you're all in step, okay? Because this is a slightly delicate thing, and this only happens in C++, okay? So that's why it's important, and it is going to be significant in your midterm, and that's why I'm actually spending a bit more time on it. So some function called read words, yes or no? That function may be main, right? Or some function that main called, some function called read words, yes?
Yes.
Okay, good.
You mean in the same CPP file, there are other main and has the same function name as this one?
No. So let's scroll down to the place where we're calling read words in that program. Just whoever, Mark, Mark, Chandi. Right? Actually, you have the code. Scroll down to the place where you call read words. Where do you call read words? There you go. All right, right. So in this case, main call generate strings. Yes, there is a call to generate. What is that? Generate package.
Lucky sentence.
Yeah. So main called that. Yes. There's an invocation to that function in main. Yes or no?
In main, you mean?
Yeah. In main. Yeah. Go further down. I think main is your
It's
last.
usually at the very bottom.
Yeah. Generate default lucky sentence. And yeah. So main. So it has to be called from somewhere. If it's not called from somewhere, it's still going to be there, but nobody will ever know. Yes. So someone has to call it, and we know that main is called because the operating system guarantees that it'll call main when the program is invoked. So every function in here is going to get called somewhere. Okay, now when that function is called, this is going to get invoked. This code is going to get invoked. That code is going to get run. So when generate, what is generate lucky sentence, right? When that function is called, go into that function now. Go into that function. Where's that generate function? Right. So that function is going to call read words. Yes or no?
Yes.
In the fifth line of that function or something, right? Or the third line. The third line of the function says read words, yes? Which means when that function is called, then it is going to call read words. Yeah? So it's like a chain of command.
I see you go here.
Yeah, so it'll call read words, yes?
Yes.
So when
Yes.
read words, yeah. So when read words runs, it knows, well, I'm running and I've got two parameters too. They told me what file to read the words from. Yes, that's my first parameter, file name. Yes or no?
Yes.
Right? And the second parameter is a container inside of which to put all the words I read from that file. It's a vector of words, a vector of strings. Do I have a second parameter, which is a vector of strings?
Yeah.
Yes.
So I have these two parameters. Now my job is to read the file and take the words and put them in that vector. Yes or no?
Yeah.
Yes.
Yeah, okay.
That's
All
what the
right.
push
Now,
back does.
sorry.
That's what the push underscore back does.
Yeah, exactly. So it's going to read words and push them in the vector. Now, in C++, anytime you pass a parameter, that parameter is not given in the original form. Well, it's in the form. The original parameter is not given to the function, right? This always happens in C++. Not, you can't assume that's going to happen in Java. It does not happen, okay? When I call a function with a parameter, that function will never see my copy, my original parameter, right? So it's like the mafia guys, right? When they want to send a message and they send, I don't know, you send a copy, you don't send the original, right? So because you're scared the other person might clobber the original, right? So it may change the value. So C++ gives you that guarantee. That is why it is so, we can feel so comfortable with calling many of these functions with our own objects, is that we are confident that the compiler will only take a copy of the object and call that function, right? So and I think this is a distinction that everybody needs to get used to, is in C++ is always copy. But if we got a copy of the container, the vector of words is a copy, right? Vector of strings is a copy, then anything we put in that box is going to be destroyed, because the copy will be destroyed, right? I'm not changing the original. Main has the original. So in this case, main has got to give us the original, not the copy. Yes? The way you indicate that to the compiler is in the signature of the function. You would say ampersand before that parameter. If you have an ampersand before the parameter, that means that when this function is called, right, that parameter is the original, right? It is the original and not a copy. Okay, so it is going to take some time. It is going to take some time to completely understand that. So after this class, I would highly recommend that if you don't understand this, just think about it for an hour or a couple of hours, right? It'll take at least that much time, right? You have to think about it and think about it in different contexts and say, hey, what happens here? What happens? And only then you'll truly get to understand this, okay? No amount of just thinking about it or thinking about me explaining it or me explaining it, it is not going to help. I can guarantee that, right? I can tell you, oh, copy and, no, all of that is just some, mental slideshow, right? You got to try it out. You got to try it out and say, well, that's what happens, right? When I have an ampersand and I make these changes here, you should experiment. With ampersand, I make these changes, those changes are not reflected, right? If I don't have an ampersand, if I have an ampersand, the changes are reflected. So those are things that you should. All right, is everybody okay with that?
Yes. And I think the problem I'm at is I keep searching what is the meaning of ampersand back.
Yeah.
So it didn't tell me the answer.
Yeah, no,
And the
that's
vac
what I
is
said.
basically
That's
the
why
name of the
I'm
parameter.
I'm thankful that you brought it up, because today being midterm, I can guarantee that more than 50% of you are going to go online and say, even after reading Michael's modules, right? You go online and say, what is the meaning of ampersand in C++, right? And more than 50% of the hits will be wrong, right? Even though, Google tries to do a very good job, but, it doesn't know. Even Google doesn't know. When you go to Google and say, what is the meaning of ampersand in C++, right? Even Google doesn't know. Well, maybe it can, right? Technically it can. Theoretically, Google can figure it out, because if you're an open person and you have your entire history shared with Google and your search history and all, Google will have a pretty good mental model, right? Or a computational model of you from your searches, saying, hey, this particular user ID search for beginning fundamentals and so on and so forth, search about parameters in C++. So when they say ampersand, and what is the meaning of ampersand in C++, based on that mental model that we have, computational model of that person, intersecting those two, this is the probability of 80% likely that they want to know about this than that. So that all of that is possible, right? Computationally. And those are the things that companies like Microsoft and Google are building in, right? And Netflix, you switch it on, automatically you get, what you want to watch. And those eventually that's, or, you don't even have to switch it on, right? Anytime you say I'm in entertainment mode, you just close your eyes. And then after 2 hours, you say, wow, that was fantastic. Yes. Right? And you can share that with your friends and everybody online. Eventually, maybe you'll build a system like that. Okay. All right, good. If everybody is okay with everything else in this code, we can actually now close this project and start a brand new one. Okay, a brand new one, which is essentially going to say, no, before we do that, let's do this. Okay, before we do that, go to your main, where, no, not generate. Go to one of your generate default lucky sentence or something, right?
Professor,
Yeah.
I think Elizabeth has a question.
I don't even
Can
see
you hear
that.
me?
Yeah, I do. Yeah, you should just speak up, Elizabeth. Did you raise your hand?
I said something a couple times.
Sorry, I'm so loud. All right, good. Go ahead. Yeah. So.
Yeah, so just to clarify, so basically the ampersand before this little vec says that we're like if I'm thinking in Python, it's kind of like we're just altering the global variable like copy, like the one that's available to all functions.
No. Ampersand does not mean it's global. Ampersand just means that it is global between, actually that's, you brought up a very nice way to think about this. Thank you, Elizabeth. Okay. So when you have an ampersand before a variable, you can think of that variable as a global variable, except it's a very, very special kind of global variable that's only visible in this function and the function that called it.
Okay.
Right? Because it's exactly the same thing. They both refer to the same guy.
Yeah.
Right? So you can think of that as a global, except it's not truly global. Other functions can't access it. Only these two guys can access it. So that's a fantastic way. I think, I don't think I've ever in all my years come across this way of looking at the passing by reference, right? Passing by reference essentially means promoting a variable to global level, but restricting the scope of the variable to the call function and the caller. I don't think there could be a better way of thinking about ampersand. So someone remember this and share this with the other students, maybe in class or maybe in Reddit or chat or something like that. Because I think that is the best way to understand this. And I spent like 25-30 minutes trying to explain, passing by copy and pass by reference, and this is what happens. And that's, but if I had said what Elizabeth has said, I wouldn't have ever had to spend so much air on this, right? Ampersand in front of a variable basically means immediately that parameter is now a global variable, right? Maybe referred by different names, right? You call it A and someone else calls it B, doesn't matter because they both mean the same thing, right? So when you put an ampersand, the ampersand promotes it into a global variable.
So, like theoretically, like if every single function in our program has the ampersand, like it would be like a de facto global variable.
No. The thing is, where do you mean the ampersand? The other functions, let's say take another function and it doesn't have an ampersand. Other functions don't get vec passed in by parameter, right? Only
no, but like if it did though, like I know that not for our program that we're looking at here, but like if we had a theoretical program where all of our functions were like passing that parameter and they included the ampersand to denote that they wanted to change the original.
I see. Yeah. Right. Yeah. Thank you for asking. Now, technically, it's possible to do that, right? Technically, you can pass everything.
Yeah, I mean, not that it would probably never happen, but like, if all functions can access it, like it would.
That's what happens in Java. Think about it. In Java, every time you pass an object, you're basically passing the pointer to the object, which means that if I pass an object to a function in Java, right, and that function changes the object, right, my object got changed. Yeah, so it's kind of crazy. And so, and in fact, if you wanted to do it the other way in Java, it's really, really hard. How would you actually pass by copy in Java, other than primitive variables? If you have an object, right? So in Java, it's actually, so C++ actually makes it possible to do it both ways as you wish. In many other languages, you don't even have a choice. It's really, really hard to do it the other way. So, so technically, it's possible to do everything by reference. You say, I'm only going to pass by reference. But if you pass by a reference, what happens is that, and that's why C++ is even more object-oriented that way, because it insulates everything so hard by default, right? So it is impossible for a caller to change something in me unless I let the caller do that by putting by allowing the ampersand thing. Yes. So that C++ gives you that power, and then that's in me, right? I can choose whether to do that or not. In other languages, it's contrived. It's very hard.
And so we can do this designation of ampersand for, we don't need to do it for only vectors. You can do it for anything.
Yeah, that's what I said. If a function returned a value, that value also can be a reference to something inside of the function, as long as you can guarantee that thing is actually alive, right? Because if you have a variable inside the function, assume that that's the opening brace and that's a closing brace, and here's the body of the function, right? Mm-hmm.
Yeah.
Right here, the body of the function.
Yeah.
Right? And you declare a variable here, that variable will die here, right? So
yeah, of course. Yeah.
However, if you can guarantee that there's a variable in here that won't die when you hit the closing brace, for example, that variable is global, right? If the variable is global, it won't be destroyed here, right? Or there's another kind called a static variable, which we haven't encountered yet. It's a static variable. So then you know that even though you hit this closing brace, that variable is still alive. Then this function can return a reference to that variable instead of a copy of the variable. And so those are things that you'll encounter too, right? Later on, you may have to write a function which internally maintains state of some kind, right? And cannot afford to lose it between invocations. It's a bad function. We should not write, technically, if you, software engineering wise, I think the fewer functions that you have that are, the word for such a function that does not maintain state at all is called an idempotent function. Have you ever heard of the word idempotent in mathematics? How many of you have done math or the terminology idempotent in math or philosophy or something else? What is it? Have you, hands up if you have not heard the word idempotent before? I see. Okay, here's quite a few. Idempotent means, idem means equal, right? Identity, right? Idem means equal. Idem, Latin, I guess Latin, I don't know, right? Potent is powerful, highly potent medicine, right? Or, omnipotent, impotent, right? So potent is powerful. So idempotent means equally powerful. So what does it mean? What is it? So when a function, a good functions usually, or easy functions, right, are idempotent functions, meaning that they are predictable, right? If a function is not idempotent, the behavior is not immediately predictable. It's predictable using other external factors. What I mean is that if I call the function a trillion times, every single time the behavior and the return value should be identical. So then the function is idempotent. Now, those are the kinds of functions that are extremely useful. And we need to know how to build, because you can build bigger and bigger scaling blocks, right? You scale out bigger and bigger just by putting together idempotent functions, because you are 100% certain how they'll behave, right? It's if you're a coach, I'm not a sports guy, right? I bet if I go and talk to a sports manager or a coach and I say, there's a bunch of players, they're all predictably good players, but there are other players, some of them are like rock stars and some of them are like, total, weirdos who will actually end up playing for the other team, right? So you can take your pick, but you can only choose from one pool. I bet that the coach will say, no, I don't want the place with the rock stars because there's some bad eggs in there. I want the average players, but they're predictably good players, because with predictably good, with my expertise in deploying their strengths in the right places, right, then we can have a fantastic team. So predictably is, so for a computer programmer, from that perspective, functions that are predictable, you can build great things out of using your own ingenuity to bear. You can say, I can put, but if the function says, I can't promise the exact same behavior each time because I maintain state internally, right? Every time you call me, I'm going to change somewhere. You know, I got to stay inside. I'm going to change every time you jiggle, right? So then I can't put you in a place that, you know, I can't predictably, you're a loose cannon, right? Like in a company, I can keep promoting you to a highly, you know, critical position because you could just fire off anytime, right? And so predictability is so important in computer. So that is why idempotence is highly useful. And, you know, idempotence has been around ever since Turing, right? And from the birth of computer science or computational thinking or logical thinking, mathematics, right? But a family of languages called functional programming languages took that to an extreme. Right? I don't believe in taking anything to an extreme. Everything has its place and, you know, needs to be used where it's supposed to be used. But there are people who basically just get married to a particular kind of language or a particular language and say that language should be used every single place. No, that's not the case, right? But functional languages are good in certain places, in certain. And so there are languages, functional languages, right? Like Haskell and Lisp. They're called and they're. Every function is necessarily an idempotent function, right? So, and you build on the idempotence, right? And that's one of the central core concepts of functional programming, at least as far as I remember. Maybe I'm wrong. We've got to look that up. But we did have a student a few quarters ago who was very, very passionate about functional languages in CS2A. And right now, he's in CS2C. So and I think he's still passionate about functional languages. That's because he hasn't yet finished CS2C, right? Once you finish CS2C, everybody's favorite language becomes C++, right? So, all right. So there we go. So does it answer your question, Elizabeth? I think it was a very long-winded and perhaps tangential answer, but that essentially is what. So idempotence means that you get this exact same behavior from the function each time. It doesn't maintain internal state. I don't know where we were going with that. So yeah, when we write functions, we can set ourselves up for programming success, meaning that we can make our own jobs easy, right? Many people say, I started out writing a program, but then, you know, I gave up because it became too difficult, right? Many people give up jobs because it becomes too difficult. And once we've done that enough times in our lives, right? Like writers have this advice saying, you know, if you want to become a good writer, start writing, because the first 1 million words you're going to write are going to be total trash anyway. So you're going to write the first 1 million words and throw it away like that, you know, with programming. I don't know where we're going with that, but idempotence. With programming, in order to write, in order to set ourselves up for reduced work, right? Not in order to reduce the chances that we give up, right? So we give up because things become too hard. Why do they become too hard? Because we followed wrong practices early on, didn't do things right. And so we put things together, it worked until it got to a stage where it got unmanageable and then became too hard, right? And then we give up. And that's because we didn't do things properly. So if you did things properly, because millions of people before us have done exactly the same thing, right? We think, oh, I got something to work, oh, now it's got too hard, I'm going to give up, right? So we followed that track. And millions of other intelligent people just like us have done exactly the same thing. And they've got to the place and said, too hard, come back, right? So they say, and then they start thinking and say, why did we do that? Why did we, so many people have gone there and given up. So we've got to form some rules so that if you follow those rules, you won't get to that place and feel like giving up. So that is the reason why we have all these rules and why you need to go through this particular track of learning C++, even though it may seem that, oh, now I need to master the ampersand and why do I need to make, right? So we try to come up with these examples that are entertaining, but these are bits and bolts that we need to totally master so that we reduce coupling. So when you have multiple a program with lots and lots of functions, and these functions are all interrelated, right? This maintains state and that maintains a variable that's referred to here and by reference and globals here and there, all connected, right? Then you can imagine this graph in your mind. Lots of these functions are nodes and lines that connect them. The graph is a big muddle, right? Because lines going everywhere and it's like, you know, a bunch of chopsticks thrown on the floor. And so that is an example of a system that has been engineered with lots and lots of coupling. A coupling is when one thing is connected to another, right? So and then the more couplings you have in your code, and the less patterned they are, you can have couplings that are, you know, that follow a strict pattern, right? Two data structures and coupled, right? Like that, like a ladder. So that's good coupling. Okay, right? You can abstract that into a data type of its own. But if you don't, but otherwise, if you have couplings like chopsticks on the floor, they're basically screwed at that point, right? So, but how do you write programs? Because if you take a self-taught programmer or a beginning programmer as a kid, our urge really is to get things working, because we want to put something together and show mom and dad and say, hey, right? And so, and then if mom and dad says, that's fantastic, you're a genius, that basically triggers the wrong kinds of juices in our brains. And then we start craving more for that appreciation rather than for learning. And then we start cutting lots and lots of corners. And we cut lots and lots of corners so we can get, reward A, reward B, which is better than reward A, reward C, which is even better than reward B, all cutting corners. But the cutting of corners catches up with us. So when we get to reward number J, we're basically totally stuck, because we can't go to I, J, J, K, L, and because everything, all the corners we cut basically are like thorns around us. They prevent us from moving further, right? So so we say, well, let's not cut corners at all, right from the beginning, or at least get a little bit of reward, but also train ourselves not to cut corners. It's going to be slow. It means that I'm not going to get my next lollipop from mom and dad, or next word of praise, right? The best thing at all of all, of course, is to just completely give up on praise and appreciation, because you don't have to be, because that's coming from outside, right? Anything that comes from outside is totally worthless, because that could come, that could go, right? And if you're banked on that, and if that goes, you're screwed, right? So the best thing is just give it up and say, well, all of that is useless. What I want is really the satisfaction of knowing how this thing works, right? Then you can say, I don't care how long it takes, because if it's going to take like 10 days, and then mom and dad or whoever this person is not going to be impressed with me anymore because it took me 10 days and most other people it took only 5 days. Yeah, I don't care really at that point, right? Because I don't depend on them to validate my interest in this thing. So then you say, it doesn't matter to me how long it takes, but I just need to master that, right? So then you can sit down slowly. Well, not today, maybe tomorrow, next week, whatever, but you get to it, right? Because otherwise you never get to it. And that's the risk. The greatest risk with development of any kind today is not that people cannot do something, right? Everybody can do everything, right? It's just that most people cannot get to it, right? And they cannot get to where they want to do, what to do, because of all the hardships that they've built for themselves. And that's where it is. So coupling, we started talking about coupling, and we're talking about something totally.
So can we talk about some of the performance differences in a program that uses pass by copy versus pass by reference?
Yeah, sure. So
when I think that when we talk about sort of how they perform differently, and maybe throw together an example, I think that will illustrate the difference a lot better.
Okay. Well, we can play with this example right now. Your question was, you want an example where you pass by copy and pass by reference, right? Two different ones?
Yeah, and see how they perform differently, and why this kind of process exists.
Sure. Okay. How about this, Mark? To tell me if it's a good experiment. Let's get rid of the ampersand in that function, read words, and run it, and then see if it works. If it doesn't work, we can try and figure out why it didn't work. Would that be a good, and then we'll know the reason why we put the ampersand and then put it there. That way it'll be very instructive. Does it sound like a good experiment?
I'd say so. And it looks like Chen
is okay, let's do that then. Let's do that. Hey, Peter's here.
Since we're not using the version with the files in there.
Right. Okay. So now we took out the ampersand, and this is what it does. And someone should try and explain why it did this. Right. I'm not going to chime in at all. Okay. I've been talking all the time. You guys are basically tuning out. And I think I saw Elizabeth yawning a couple of times too. So, all right, I'm basically going to stop. Right. You guys talk and talk about why it's not working. And even if you're wrong,
I stay up way too late. It has nothing to do with this class.
No, it's all right. I'm just kidding. All right. So, but anyway, you guys should talk. I'm not, even if you're wrong, it's okay, right? Because you'll figure, you have to figure it out before the midterm, right? You got only until midnight to take the midterm. So even if you're wrong, you're basically screwed in the midterm. So you have to figure it out, either read it or talk to your friends after class. But if you talk about things, the ampersand notation amongst yourself, each of you, right? Explain to each other. If one person explains it, another person says, hey, that's the wrong explanation. You're confusing that person, right? This person should chime in, and so on and so forth. So have that lively discussion, go on. And when you're ready, what we'll do, we will take this program and then change it so that instead of the C out, we basically say display, call a function called display, right? And then that display will do the C out. But then we'll make sure that you can comment out the display function and use someone else's display function from another file, right? And that display function could be fancy, right? It could do some crazy things there. So we can try all that. I think we have a lot of time. Yeah, I think it's only 8. It's only 9. We got a whole hour, right? So I'm basically just gonna. Do you want me to? Would you feel better if I just stepped off camera? I can do that too, right? Because if I'm on camera and I'm watching, you guys may not feel. Comfortable conversing with each other. But by the way, my only fear with switching off the camera and muting myself and going away is that then, silence could take over, right? And then you guys are not talking at all and you're waiting for someone else to make the move, and that'll never happen, right? That's like 2 people at the bar, right? And they can come alone and go back alone like that. So you got to make sure that there's no silence, right? So, and don't let silence take over, right? Because it's contagious. I told you that, right? So can I go? Can I just switch off? I'm not going to go, right? So you can just call out to me. You just say, hey, Anand, come back, and I'll come back, right? And I'm just going to be here, right? I'm just going to be here, around here anyway. Yeah, is that okay? 5 or 10 minutes, at least you just talk. You should completely feel free to blow, tear down each other, right? Someone could give the right explanation, and you should say, no, that's wrong. That's fine, right? And the other person you can have a debate and say, why that's wrong. You can try experiments and say, well, you know what? I'm actually going to do an empirical test to show that I'm correct, right? So you can actually bring science in, and you can have a lot of fun, right? So, and this is the last class, and actually there's no agenda for this class, right? Because technically, not technically, right? Only the final, on the day of the final, or the week of the final, I'm not supposed to have any classes. Midterm, yeah, well, some professors do have classes. I didn't used to have a class on midterm day. But today is basically a fun class, right? So no agenda, you should just feel free to play around. All right, so can I stop, or do you want me to talk about something else? Can I mute?
Yeah, no one's going to stop you from muting.
Thank you.
So I guess the first thing that we should do is take a look at why we're getting any sentences at all. And just looking at the main declaration might give us some hints.
I have a quick question before that. So we have 2 parameters in this void read words function, right? So when we're calling this function, when we're calling adjectives, is this a vectors?
Yeah, that goes into the vector.
That is this one, right?
Yeah, and it's declared as a string vector, as indicated by the word string and in between the little greater sign, less than greater sign. So
the meaning of the vec here, is that pinpoint like the number of an array, or what is the vec means here?
That's just the name of the vector. So it could honestly be anything, but that's just the name of the argument.
I see.
But because we declare it as a string, it has to be a vector of strings.
I see.
So basically, whatever we pass in has to be a string vector, basically.
So you can feed it numbers, and it'll treat it like a string.
Got it. Yeah, my question is solved. Thank you.
Now, I'll be honest, I'm not sure why, what happens when you put expt next to main, and that's just what I'm thinking we should go to, where main is declared, and just kind of get a feel for what's going on step by step.
Oh, you declare expt is to read the file.
Right, but we didn't feed it any files, so it's possible that and there, the pass by reference might not really matter.
Wait, even after I put in the %, why it is?
Well, that's because you haven't recompiled anything.
Recompile.
Yeah, you have to hit the run button before you start to like
Oh, I see.
calling the function. Yeah. So if it works like this, you know that.
XPT.
Right.
So
So we
it's
can
the-
see that there is a difference here between when it has that and when it's passed by as copy and passed by reference.
Yes.
So let's take a look at where main is defined so that we can get a sense of what's going on here and then start speculating on why it's behaving this way when we don't use pass by reference.
I think main is here. And
so expt, I think, is a command line argument, which is triggered when your argc is equal to not 1. So you've got two conditions. If argc equals 1, which is what happens when you don't have those command line arguments, and then when you put expt, it generates package lucky sentence, which we can look at by scrolling up a little at the generate package lucky sentence function, right? And here it is that we're looking at, what is it, 4 calls to read words? And it's trying to look in the text files and feed the values from those text files into a vector adjectives. And we know it's a vector because that's how it's defined. Now the question that I'm still not 100% on is why, when we feed this as just a regular vector and not as a reference, do you think that we're getting blank input?
I think we do because I think one of them is check in if the vector have anything in return, it just returns an empty value. Doesn't it? Or these are the spaces between the A and the on. Maybe they're the spaces in the word. And you still have an empty vector.
What was your question?
Well, why is it that we have blank spaces, basically, when we're passing this as a regular vector and not as a reference?
I think it's because, like, how I think about it is when we pass by reference, whatever changes we make to the object inside that function live outside that function as well. But when we don't pass that as reference, it only lives inside this function. You get what I'm saying?
That makes sense. The question is, why do we still have words at all as a follow-up? Like, how do we have a and Anna?
Because
that's in the
yeah, it's here.
In the article and preposition, yeah.
So is that actually called when we're using the version of main that has a command line argument? Like if we scroll down to, I think it's generate package lucky sentence. Yeah, it looks like we do have string, adjective, and we've got get random word. It's probably because of string art1 and string art2, right? Are these these don't actually refer to any of the vectors, right? So I betcha if we were to mute that out and sort of delete it in the cout portion, would we just have a blank line?
You mean delete?
Well, we can comment out those and then delete the art1 and art2 in the cout side, which is at the very end of that function. Oh, wait. Yeah.
Sorry.
So art1 and art2, if you take those out just temporarily, art1, not edge.
Oh, sorry.
So if you go to look at the get random word from vector, the function that we created at the top, it measures every every value that you pass it on. So if it's like if it equals 0, if it's an empty, then we just return an empty string at that point. So I went like maybe this is why we have these empty strings plus the spaces we have in the cout.
Yeah, it makes sense. I'm just trying to see if we were to delete art1 and art2 in the cout portion, will we get a completely blank sentence when we call main with
I see.
So I suspect that's exactly what's going to happen. And then /main.
Oh, it's still running.
Oh. Okay, it might be, I might have triggered some kind of like endless loop, unfortunately.
Well, I wasn't quite understand what Turkey said before that.
Yeah, could you speak up, Turkey?
Oh yeah, definitely. If you go all the way to the top to the get word function, get a random word function.
Get random word.
Here you go. The first one, the first function. Yeah, here. So if you notice that it takes the vector, and if the vector is empty, which is if you see if vec size equals 0, that means there's nothing in. The string that returns is an empty value instead of actually giving an error. That's why we have these spaces. And the spaces we see is just the spaces in between the cout.
I see, yes. Get random word.
So maybe a more demonstrative example of the difference between passing by reference and passing by copy
this one is
would be to. Oh.
Sorry.
Oh, yeah. Still have on. That's interesting.
Because I didn't get the PP off.
Yeah, we don't have a package on the preposition too.
But yeah, if we Control Z everything and then go to the very top and remove that ampersand on that first definition, I think everything should be completely blank, don't you? Just because it would return sort of an empty vector.
Well, right? I don't think it would, because for the empty string, it is get random word. But for the article and preposition, it's not get random word. It's get random article and random PP.
Yeah.
So it's two different.
The reason I think that that would be more demonstrative is because we apply that first function to all these other get random word declarations, right? For example, if you go to the top and look at like the third function that we declare, you'll see that at the very end it says get random word from, oh wait. Can you just scroll a little bit up again? I forget the name of the, yeah, get random word from vector. And we do have an and vec. So we're passing by reference a vector there. So I bet you if we delete that and vec at the get random word from vector, which is used in pretty much every declaration, even your default main would be impacted in a way that I don't think you're going to get any words. Let's just run it and find out. And yeah, kind of, we're just slicing up the code at this point, but it's demonstrative to sort of what? Okay, I'm wrong.
Well, if we get the PP off like the article 1 and 2, definitely it will be a bit blank line.
Interesting.
Wait, can you go to get random PP?
Get random PP. You mean here?
Yeah,
or...
go to that function.
Okay. Random, yeah, here.
So I guess it's because we have
Because we're returning the string there, right? We're returning a random, no, we're not returning a random.
Well, it's.
Oh, yeah, we are returning a random word from this vector, right?
Yeah, so these vectors are hard coded in there. So even if you're passing by copy, you're going to get something.
Yeah, because it's always returning at least one string, right? At least on, under, or over.
Yep. That explains why we still have words in here. Even when we take out the pass by reference definition in our functions. Anyways, is this explaining to everyone how these behave differently, pass by reference versus pass by copy?
I'm still confused.
Yeah, it's reasonable. Anand, you still there?
I do have a file I created explaining the pass by reference thing. Maybe if I share it here.
Yeah, sure.
Second. Okay, can you guys see my screen?
I can see it.
So
you could zoom in to make the text a little bit more legible, though.
Yep.
Looks better.
So we have an initial value of an A equal 1. We have an initial value of B equal 2. Then we pass by this, like we pass these two to a function called add1. And if you notice that at one of the values have the ampersand. And we're going to show the value of these function, of these values in each inside and outside the function. So if you run it, you can see the differences that happens in it. So it starts as 1, 2, and then we pass it here, and it reads 2, 3. Then when we come back to check the value A and B again, we notice that B changed to 3, but A stayed 1.
Could you make the variables the same name, so just so it makes more sense, like A and B? Oh yeah, you could do that, and then just make
Your plus pluses are yeah.
Yeah, that should make more sense.
Change this. So
and
yeah,
also the J right there.
So we see that in main, it changes after we pass it there, but the A is still the same because in here it's an instant, and after the function runs, it just clears. So it doesn't.
Do me a solid, and when you initially define B, set the value to 1.
Okay.
Great. Yeah, that way it's, there you go. So does that illustrate the property for everyone? Thanks, Turkey. That really helps.
Yeah. I don't know how to turn this on. There.
Yeah, so the and is passing by reference, and if you don't pass by reference, as soon as you leave that function, the definition of that variable kind of goes back to what it originally was.
I also shared like a link in the chat, so like it's like a visual representation of what pass by reference does.
Yeah. Java.
It's the same idea, so
yeah.
I think it's fine.
So in the project that we're going to be working on today, don't we need to have the function returning just one string so it can be easier to like make any motion or graphics on it instead of having it as a cout?
Definitely one strategy. Before we proceed, are there any other questions anyone has? Especially about passing by reference. Okay. Well, I guess if that's that sort of resolves that issue, and everyone's pretty confident about passing by reference versus passing by copy, we should probably bring the professor back and talk about what we're going to do next. What do you guys think? Hey, Anon, you still there? Professor Anand. Is there like a ping function? Oh, there he is. Okay.
Yeah, what's up?
So I think that Turkey illustrated the difference in performance pretty clearly, and we've sort of explored how that happens in a vector context with the code that we wrote. And I think we're ready to move on.
Fantastic. All right. Okay, great. I'm so glad you guys were able to spend time on passing by reference and copy. This is the only concept really that you can't learn from another class, right? Because they don't teach you this in Java or Python. And so this is the part in C++ that you paid for. All right, cool. All right, so someone pick up the screen, and then what we'll do is modify this program to use a display function, and then write the display method of our own. Hopefully someone has created a pack, right? How about this, okay? If you guys are not going to select of your own, let me see. Just do Star Wars, okay? Create a pack for Star Wars with 10 Star Wars nouns, 10 Star Wars verbs, adjectives also need to come from Star Wars. I don't know what kind of adjectives they'd use, you know, and so on and so forth, okay? So 4 of these files, 10 of each, right? 10, create this. If more, yeah, another person could do Harry Potter. Another person could do, you know, Game of Thrones. Yeah, whatever is the, you know, flavor of the day. So, but we'll try at least with one of those today, right? Okay, so can someone pick up the screen and we can start coding. If you have a good internet connection, we can just start coding. And I don't believe we need to hit the browser for anything really. So it doesn't have to be complete. If you want, you can do it in your IDE, and then you can share that code some way. Hey, Maxim, I actually don't remember you taking the screen at all.
You mean recently, or?
Did you? No, actually, maybe I've forgotten completely.
Because I did early on.
Oh, yeah, right. I think it was lecture number 3 or 2 or 3.
It was like, yeah, lecture 2 or 3.
I remember now. Yes, that's right. You are actually on the, quadrant number 2. quadrant 4 of the Zoom. Yes. Okay, all right, anybody can pick up the screen. Anybody with a decent internet connection, okay, pick up the screen. And we'll, you know, and let's get this code, and then we'll modify this code and then go on to the new visualization part. We got, you know, 30 minutes, more than enough, right? Famous last words from last class. But we actually did manage to finish it last class, yes? Okay, all right, good. Chanyi, hey, Chanyi, you want to go again, or do you want to give someone else a chance? All right, if nobody else wants to go, Chanyi can go, but Chanyi just went. So I think if someone else wants to go, they get precedence over Chanyi, but otherwise, I'm very happy with Chanyi taking the screen, okay? Nobody else wants to go? Wow. Okay, Chanyi, take the screen. You're an Xcode, right? Is this Xcode? No, this is Replete. We'll do it in Replete. That's fine. We'll just do it in Replete.
Because I don't know how to input the file in the Xcode. I tried.
You want to try? You want to do that now? It'll take like 10 minutes. No, 1 minute. That is exactly the same for VS Code. Any other IDE, local IDE you have, it's the same. Just open up Xcode, create a new project called Lucky. Right? Open up Xcode, create a new project. And hey, guys, you can follow this step. You know, anybody who has a Mac, just follow this this sequence of steps for.
Well, I already created one. And these are all the
version. Did you? Hey, Chanyi, did you explicitly have to set the theme to dark mode, or is it the default theme you get from Xcode, the latest version?
I downloaded it recently, and I think they have 3 different versions.
You change the look and feel, because you know the look and feel is more like VS Code. But mine doesn't look like this. Mine looks like the traditional Xcode, white and black, and you know. So
I think we can change it when we're
no,
setting.
that's what I mean.
the first-
Is the default
Yeah,
there? Have they made this the default
Mhm.
now, the new default? Anyway, let's not worry about that. So you've created a project. You got a main, verbs. Oh, I see. And what is your question? You're saying that it doesn't work?
Yeah, because in the Reddit or Replit, I can put // and main and then type the name of the file. But in the Xcode, I can just click run.
Yes, in
And-
Xcode. Yeah, in Xcode, if you run it now, you'll only get the default. Now you got the default, right? The messy apple. What was it? The messy apple slowly. Hey, your verb tense is all wrong. All your verbs need to be past tense, because then it will say slowly drank under a messy orange. How come it's getting the same adjective both times? You know, messy apple and messy orange. You can look into those details later. Okay.
Okay.
Anyway, we're going to end up using these packs. This is just a default. Okay. So, all right. Good. And by the way, the packs need to be in a folder of their own. We'll get to all of that very soon. Now, what you can do is
wait, it's
what
not
are you
file.
doing?
I should create a new group, right?
No. Don't create a new group. This is good. What we want to do is go to your main and go to the place where you go to generate default lucky sentence, right? You have the C out, so on and so forth, right? So instead of C out, let's just create our own stream right on top, saying above the C out line, just go above the C out line.
C out, this one?
Yeah, just go, enter. Now you say I string stream. Remember, okay, this is what we've used all the time, right? And all the other, this is a standard idiomatic expression. You can just remember this. I string stream space IS. Oh, not IS, no, it's O string stream OS, right? Now we want to output into a string. What we want to do is concatenate multiple strings and things into one thing, right? So you'll see what we're trying to do. OS. Yeah, you can just say semicolon. You use default initialization should be empty, right? Semicolon there. Okay, enter. Now change the C out into OS.
Change the C out into OS.
On line 87 and 88, just change C out into OS. Yeah, this is the thing. This is the object that we have just created. Yeah. Okay. Yeah. Again, hey, Chanyi, I think I mentioned this to Yen also last class. You're backspacing, or also when you're selecting words, you're clicking and dragging and all, right? This is a very common bottleneck that beginning programmers have. Okay, and it's the sooner you get over it, the better your programming life will be. Try and minimize situations where you have to backspace one at a time, right? Or drag one at a time, because every time you do that, you have to be conscious. You can't just let it loose and let it do its job. Yes, you got to be conscious. You got to know, okay, when I get here, I got to stop. So that's all extra mental load. Why? So just double click, right? Get in the habit of double clicking, triple clicking. Learn these hotkeys. This will save you a great deal of mental effort, right? Not just physical effort. Okay, all right. OS. Now at the end of the function, after the right? Yeah, enter. Just return os.str. os.str. Now what that's going to do is, instead of sending it out to C out, you've sent it out to an imaginary stream called os, right? And then from that stream, you're getting the string that would have appeared on screen and returning it. Okay, so you're returning str. It's a function. Str is a function.
Str is a function.
os. Str is a function that is attached to the os object. That, we haven't talked about objects so far, so sorry. Okay, open close parentheses. Okay, so that basically says, now it says, I don't know what O string stream is, right? So go right to the top, and you have to include, I think, S stream.
I don't think we're supposed to return that, are we? Because it's a
change void into string. Change void into string.
Oh, okay.
And thank you, Mark. Okay, and also it doesn't know what O string stream is, right? So go right to the top and hash include S stream.
Hash.
Like hash include right at the top, right to the top.
Yeah, not here, but at the like line 5.
Hash include
S stream. You know what? I have a vague. We did actually put it in the very first. We put it in, and then for some reason we never used it, and then we got rid of it. Okay, now we're S stream and then close. No.
Wait, you mean S stream?
Yeah, close. Like S stream. like a file stream, string stream. The previous line is file stream. This line is string stream. You're including
Well,
those.
if you look at line 2, that's exactly the same, isn't it?
Hey, you got a stream. Yeah. I'm sorry, Chanyi. Just triple click on the line. No, yeah, delete that line. Triple click and delete. Okay. Now, why is it underlined then? Go back to that thing there. Go back to that O string stream that we declared. Let's mouse over O string stream.
Sorry, I forgot an R.
Oh, I see. Okay, yeah. All right, cool. Yeah, it happens all the time. All right, great. Okay, so right. So now do exactly the same thing for generate. What is that non-default lucky sentence? What is that other generate thing we have? We have one more generate thing, right?
Generate package lucky sentence.
Yeah. Okay, do that there too. Is everybody following along what we're trying to do? Yeah. Done?
I think so.
Oh, you have to return. Change the
Yes,
void.
return.
Change the void to a string, and then return it.
Return.
OS. Yeah.
Right now, go to your main where you call these two functions. Go to the main where do you call these functions? Right now, they're not void anymore. They're actually returning a value. Yes.
Yes.
Okay. So say string lucky sentence equals, and on line 124, on line 124 at the beginning. Yeah. Say string lucky sentence equals
string
lucky underscore sentence space string space. So no, string space. Space.
Oh.
String space. Yeah. Hey, you are very anxious because you're on screen, right? I bet you are not going to be doing all these silly errors when you're coding by yourself. So you just need to get over that thing that 100 eyes are watching you right now.
Lucky sentence
Equals lucky sentence equals string lucky sentence equals. Okay. All right. On the next line after that. Yeah. Say display text or display sentence underscore sentence display underscore sentence. That's a function we're going to write. Display underscore sentence and open close semicolon. Yeah. And do the same thing for the other one too.
Where
you have to pass it. You have to pass it a parameter. Lucky sentence as a parameter.
Lucky sentence.
For display sentence, you pass lucky sentence as a parameter. You can actually double click that. It'll select the whole thing. Yeah.
Where did we declare the lucky sentence in the display sentence?
We're about to.
Okay.
I didn't even get that question, but I assume Mark answered that. Okay. All right. Yeah, do the same thing here.
This lucky sentence or other name?
No, lucky sentence. Because you can do that because your previous lucky sentence was declared within the if statement, right? So it comes into being there and it dies there. So you can reuse the same variable name again.
Okay.
Yeah?
Yes.
Semicolon. All right. Now above main, let's create a void. One more black line. Right. Now say void display sentence. I think you got 2 blank lines above that, but that's fine for now. Yeah. Open parentheses. String s. Okay, string space string. No, it takes a parameter. Display sentence takes a parameter. Yes. Look at line 130. It takes a parameter. String space s. You got to say string space s inside of the parentheses.
Strings.
You type in string string string.
String space s.
Yes. Okay. So you're passing the string as a parameter and putting a space before the brace. I think you have a space before the brace in other places. Yeah, before the opening brace, put in a space.
Before the open.
Yeah, because you have a space. No, that was okay. The previous one was get rid of no. You need to. There you go. All right. So inside the body of this function, we'll do something really, because this is the default, right? This is a default, and it doesn't have to. We're depending on some other engineer. We've outsourced the display job to, right? Lives in some other country somewhere else, right? We said, I'm writing a cool thing and I need you to come up with a flashy display sentence function and give it to me, right? So until that person has completed the function and returned to you, you can call that function, right? That function, their function, when the outsourced, the contractor gives you a function and you call that function with your sentence, it's going to do some fancy things like paint your screen orange and play some bells and whistles and fade your sentences, do all those crazy things it'll do, right? But you don't have that yet. So does that mean you can't test your program, the overall logic for your program, until that function is delivered to you? No. So what we'll do is, until that person gives me that function, I'll just use a a make do function, which is just going to do something really brain dead simple, which is a cout, say cout space double less than s. Yeah, left shift s. Yeah, you're just taking the sentence and putting it out on the console. Right, and then put a new line after that. Left shift and L. All right, that's it. That's the function. In fact, you can put the whole function in a single line too, because I'll tell you why we want to put the whole function in a single line, because we haven't talked about overriding, right? So let's put the whole function in a single line. Take line 121 and put it after the brace, right? Put it after the brace.
After the brace.
Yeah, just put it there. Space and then put it there. So space and then put it there. Okay, and then close the brace on the same line also. Right, and get rid of the brace and clean up the blank lines, right? And then above that line, put in a comment. Yeah, well, you actually have two blank. You put in a comment above display sentence, right? So and say space. This is just in case someone comes to look at the program and say, hey, what's this doing, right? Say this is a just call it stop hyphen gap. Stop gap means temporary, right? Stop dash gap. Stub function to be used until some external contractor writes a better version of display underscore sentence. Does that make sense?
Not really.
No, someone else. This is doing until a better version of display sentence is written. Just say that, right? Until a better version of display sentence is written. We have something that works until we get to a even better version. That's what we're trying to say. Display underscore sentence. No, a better function is written. Just say better function is written until some better function is written. Does that make sense? You guys, is that okay with everybody? Yes or no? Nobody's even speaking out.
Oh, yes.
All right, okay. Now what we're going to do is this is done. Okay, now compile it. Don't run it. Just compile. Maybe run it. It'll just produce a default, right? Just run it. Make sure it runs. Does it run? Compile and run.
I clicked it. And
did it run at all?
It's building 4 or 5 tasks.
Oh, it's still building. Why is it so slow?
Succeed.
Okay. All right. Go ahead. Now you can go ahead and. I'm sorry. Are you waiting for me?
Yes.
I'm sorry. I thought you were just you guys were doing things. Yeah, it runs, right? So now let's just set it up so that it can run with a pack also. Let's double click in open products for a second.
Open products.
In fact, better than that, just right click on random sentence and go to it in Finder. Right click on random sentence. No, in the left, in the nav bar, on the left. You see that? In the package explorer. In the package explorer, right click there and say open a terminal. No, right click on top of random underscore sentence, the folder name. Yeah, right click there. Not click. Right click. Open terminal. Can you open a terminal there?
Open.
There's no. It doesn't let you do that. All right, just show in Finder. Show in Finder. Yeah. Did you click that?
Yes.
Why is it not showing?
Because I'm just sharing one screen. Hold on.
Oh, I see. Now what I want is basically if we can open a terminal and navigate to that folder, right? Anyway, just double click on random.
Can Can you see?
Yeah, I can see it. I can see it now. Double click on random sentence, the first folder. Where's the binary? Where does it put the binary? Where does it put the compiled program? Do you know? We need to go to your settings.
This is our coding.
No, that is your source code. That is your source code. What we want to know is after it compiles the source code, there's a binary, there's machine instructions, compiled version of the program that you run now, right? Where is that program? And I think that program is in what is called the derived products folder, which by default is not there. Unfortunately, it's in a different location. What time is it now? 9:38. Okay, hit command comma for a sec in Xcode. Hit command comma. Oh, I can't see your screen, so I can't even walk you through this. Oh, you can. Oh, you can command comma. No, that's not command. Okay, command comma. No, okay, get rid of this random this folder. Get rid of the yeah. Okay, command comma.
Command comma.
Yeah. So what I'm trying to do is find the place where it is storing your compiled program, your binary, right? We can do that by hand.
Is it this one?
Let's do this by hand.
Is it this one? No.
Yeah. That's the one. That's the one. Actually, click on products and right click and can you? What is the name of the folder? What is the name of the folder?
Products.
No. Just show in Finder. What's the full path name? You want to open a terminal and change to that directory. I think that's the best way to do it. Run a terminal. Just run a terminal. No, just run a terminal.
Run the terminal.
Run. I think.
Click here.
No. I think we may not have time to do that. What we'll do is instead, I'll actually show you how to just run it inside of Xcode with the command line parameter. Okay, just go back to your Xcode, right? Go back to your Xcode, right? Now, where are the 3 data files that you had? Right, 4 data files, right? So what we want to do is right-click on random sentence and create a new folder. Right-click on random sentence and create a new folder. No, it needs a new folder. Can you create a new folder? It doesn't
have a folder. It has a group.
All right, now
you might have to
go to your Finder. Go to your Finder window where you had random sentence open. Where the
you might have to open
products. Yeah, click on products.
Folder.
Click on products and go to Finder. Click on products and go to Finder.
Finder.
Show in Finder.
And then.
Where is your binary? Where is your binary here? Is it up there? Why can't I see your program?
So go into
I don't think.
Just go into random sentence, that folder there, and I bet you it's got
This one?
Is that the program? No, that's the project file. Click on the folder. Click on the folder again.
Huh.
The folder.
Yeah, I don't know how Xcode
No,
works.
click on the folder. No, the random underscore sentence. Click on the folder name. No, the folder itself. No, that's not what I meant. What we want to do is create a folder there. So get into that folder again, random underscore sentence. Go to the place where you have those 4 files. Okay, you have the 4 files here? Good. In here, right click and create a folder. Right click and create a folder here and call it some name. Call it all. Call it all. All words. All is fine. Right? Now copy those 4 files and put them in that folder. Or no, copy, move the 4 files into that folder. Move the 4 files in. Okay, good. Right. So we want this folder to be where that binary is. Well, how can we get to the place where that binary is, that compiled program? Where is the compiled program? So we want to find. I can walk you through this. It's 9:41. What we want to do is in Xcode, in the settings of Xcode, there is a place where it puts all the compiled code. Actually, you know what? I'm starting to dislike Xcode, or at least the default settings. Maybe I should just switch to VS Code, where everything is grouped together much more nicely. Because Xcode is binaries and object code. They're all living in various different places. And it's derived data folder that's like a ton of gigabytes big, and it's getting more and more out of hand. Yeah, here's what I'm trying to do, okay? Normally, when you go to a program and try and compile it, it creates a binaries, right? You know that C++ is a compiled language. It cannot run the source code like this. It needs to turn it into machine code, and that's what the CPU can run. Yes or no? Okay, yes. Now all we are seeing here in this folder is a source code, what we've written in C++. The compiler takes that source code and turns it into machine instructions and saves it in a file called lucky, which is equal to your lucky.exe on Windows. It's to say the machine code of that program is in a file called lucky. That file is stored somewhere in the hierarchy of Xcode's, magic distribution. And we have to locate that file because our folder needs to be in that, where the file, right? So we're trying to find where that file is, and we're having a hell of a time figuring out where the file is because it's in settings, and Xcode stores the derived data from your source code somewhere else, meaning that you're only concerned with the source code. Let me manage everything else. But the headache here is that sometimes we want to go where it has the binary data, and it makes it so hard for us to do. And it shouldn't make it so hard for C++ programmers, right? It's understandable if someone comes in with a Python, or a higher level language, and they want to get some stuff done, they don't care so much about the internals, right? Then it's okay. It's understandable that the IDE makes everything completely opaque to them, right? But we're trying to do C++ here, and we need access to a whole lot of things on the machine level, and Xcode shouldn't really obfuscate or make things really hard for us and store the derived data elsewhere, right? Now, the reason I'm saying this is because I also ran into a similar with Xcode, right? The derived data folders start getting bigger and bigger and bigger because they're derived, right? It's from your source code. Your source code is only 3,000 bytes, but your derived data could be much bigger because it's linked in libraries and all these things. Now, you don't want to keep them lying around all the time, right? Because these days building is so fast. So you just have the source code, you can build the thing when you want. So with other environments like Xcode, VS Code and all these other things, I'm pretty sure you can just, everything is in one place. You can just go and keep the source code and clean, make clean, right? You're done. And that is harder, unfortunately. Hey, you know what? We can do this. We have, I'm willing to stick around and do this now. But I'm conscious that it's towards the end of the class. So if any of you want to drop off, feel free to go. Here's what we will do, okay? Go to your, run the command, Mac command called, there's a Mac command called terminal, right? Run the Mac command called terminal. Yeah, enter. Okay, now just increase the font size a bit, control plus a few times, command plus a few times. All right, great. Now, what we want to do is go to the place where you've stored the code. Do you know which folder has your random stuff?
I think just name the random sentence.
Okay, CD, change directory, CD space, random, RAND. No, is that what you called it? No, just type R and hit tab. Hit tab. Hit tab.
Tab.
Yeah, tab.
It doesn't work.
So there's nothing called rand in your home directory. So what we'll do is say tilde, just hit tilde, which is, yeah. So, no, the shift backward, shift and under the escape key. Shift under the escape key, you'll see that thing. No, under the escape key. Press shift.
Press shift.
And then under the escape key, you see that squiggly thing. Tilde
escape. What is this?
Yeah. Hey, Peter, you can come
next to the one.
Yeah. Here, you can have a cookie.
You mean this one?
Yeah.
Okay.
Yeah. Yeah, did you do that? Oh, I'm sorry. I didn't realize you were waiting for me. / and then hit tab one more time.
It doesn't work. Oh.
No. Wait. I want to see. Where is your? So say capital DESK, capital desk. We want to go to the desktop, right? Desk. No. Then I'm sorry. Capital D and then lowercase ESK. Yeah, tab. It'll autocomplete. One more tab. Oh, you got no. Oh yes. Say yes for now. Say yes. Right. Okay. All right. Tab now. Do you see random sentence? Okay. So type in capital RAND and hit tab. Just type in capital RAND and hit Q out of this. Q. Yeah, Q. All right. Oh. So can you type in capital RA and that's all. Okay. That
RAN.
No, that's all, Peter. Okay.
That's all, Peter. It's not to me. Okay.
No, that's all. Okay, I'll give it to you later. Come back. No, random, R-A-N-D, R-A-N-D. Tab, hit tab.
Okay. But when I was
enter.
when I tapped R-A-N-D and you said that's all, and I said okay, that's all.
Oh, I'm so sorry. I didn't
Okay.
realize. Okay. All right. Now do ls and then hit enter. Do ls. No, ls space dash la dash la. Enter. Okay. Now cd into cd space another time RAND and hit tab. See, this is, we're navigating into a folder and another folder inside of it, but somewhere trying to find the right. Enter. Up arrow 2 times, so we get the ls command one more time, right? Up arrow. Yeah. Okay. Enter. Okay. All right. So here you have the program that you wrote called main.cpp, right? And the folder that you created called all.
Yes.
We will compile this program by hand. Okay, let's forget about Xcode because we don't know where it's put the thing, right? So we're going to compile this by hand and then run it just like we did in Replete and all these other places. Okay, so but I want to know if you have the G++ compiler. Hit G++ and hit enter. Okay, you actually do have it. Okay, hit Control C and get out of it. Control C.
Control
C.
Control Z. C or Z?
C, sorry.
Okay.
All right, now type this command in. This is what Xcode actually uses. This is, when you hit the triangle, the play button in Xcode, what we're going to type is what Xcode is also doing. It's not showing it to you, but this is what it's doing. G++ space -O space lucky, LUCKY space main.cpp. Right? So what this command says is compile the program main.cpp, generate machine code, and put the result in a file called lucky, right? So if you hit enter, it would compile your program, generate machine code, create a file called lucky, inside of which it puts a machine code for your source code, right? So why is it taking this long? Is your Mac really slow?
It is a 2017 version.
Oh, is that an error? Oh, non-aggregate type vector. You know what? This is a funny thing, right? We didn't have that error on Replete, right? And I remember this because I told you guys, remember when you were doing the vector and I said equals and curly brace. And then I said, well, I don't know if this is going to work or not, but whether vectors can be initialized like this or not, well, let's try. And it actually worked, but it didn't work in Xcode. Right, so we need to do a later version of C++. Okay, so up arrow one more time in there. Click in the green, yeah, up arrow one time. Now before the -O, back, yeah, go. No, you need to use the arrow key. Okay, now say std equals C++. Hey, can someone tell me one of you, someone please look up online, what is the flag to use CPP, the C++ version 14 or 11, C++ 11 or something like that, or 11 or 14. One of the more recent C++ versions. What is the flag? I think it is dash standard equals C++ 11. Try that. C++, I can look it up actually. One sec.
According to this, it's -std equals C++ 20. Oh wait, 17.
Yeah, okay, yeah, let's do that. Okay.
So std equals C++ 1z, which will give you ISO 17.
Sorry. C++ then?
1z.
1z.
Yeah.
1z like that. Okay, enter.
Do I need to delete the? Oh, sorry. Do I need to delete the -O?
No. All of that we need. Well, what we're saying is that G++, when you compile this into binary, make sure to follow the standard for this year or that version of C++ is what we're saying. Oh wow. Okay. So that version of C++ understands that you can initialize vectors like this. But the default version of C++ that comes with Xcode or G++ with your Mac probably does not understand that you can initialize vectors like that. Okay, good. Now, if you do an ls-l up arrow a few times until you get the ls line. ls line, yeah, enter. You'll see a file called lucky. Yes?
I see. Yes.
And that file is 13,000 kilobytes. There's 133,000 kilobytes, 133 kilobytes. That, right? That file is a file of machine instructions. You humans cannot understand that unless you're von Neumann. Okay, so we can understand it's machine instructions, but the CPU can understand that because it's written in CPU language, in ones and zeros. You can actually run that file. You can tell the operating system, there is a file called lucky in the current directory. Run it. There is a function called main in that file, right? Run that function and then print the result. Run the function, right? And you say that to the operating system on the command line by saying /lucky and hit enter. We should see the default behavior. Enter. Is that your default behavior?
Yes.
Okay. Now you have a folder called all. Yes. So
yes.
We want this program to use the all package. We want to use the all package and generate sentences from the all, right? So you say lucky space all and uppercase.
Like this.
Yeah. Enter. All right, now let's do some organization here. Now that we're on the command line and everything, right? Create a folder here called packages, and you do that by saying make dir mkdir space packages or packs. Just say packs. Yeah, enter. Right, and move all. So you say mv space all, right? Capital A and tab. Yeah, space. We're going to move this directory called all to another directory, subdirectory inside of packs. We're going to have many directories inside of packs, right? Inside of packs, we're going to have, let's not call it all. Let's just call it default. Just call it to say packs, P and then tab, P and hit tab. Yeah, and they say defaults. Yeah, enter. No, it's not defaults. I'm sorry, it's not defaults. Did you do it?
Yes, I click enter.
Oh, no. Yeah, up arrow. We typed the command wrong. Up arrow. No, move all. You don't need the word to. I think I said to, but I didn't mean you to type to. Yeah. Okay. All right. No, don't call it defaults. Right. Call it. Actually, just call it. Turkey. You know, he's the one who gave us the spec, right? So just call it capital T URKI. All right. Enter. Now say /lucky space packs P tab, and then what we call it? Turkey, capital T and then tab. Yeah, you can just hit tab.
Yes, tab.
Enter. Right, an ingenious. What is it? Ingenious black segment healthily.
Because I changed the 4 files. I changed my own. It's from Sherlock Holmes fiction.
Oh, you did. Okay, but you still have the
article problem.
I'm trying to. No, the sentence, the tense. Because reprise is present tense, right? We need all of our verbs to be past tense. Otherwise, the sentence will look funky, right?
Yeah, and also the article.
Right. So, but you changed that. Okay, now all we need to do is go into the packs directory, go into the packs folder.
The packs folder.
Yeah, I'm sorry, CD space packs, right? Yeah, enter. Right, now do an ls-l here, up arrow until you get the ls, or you just type ls space -la, yeah.
I see.
Enter. So that's the contents. Now we're going to create a folder here called, with your words or something like that, right? So we'll create a copy of here, right? We're going to create a copy of Turkey's directory, and we're going to change all the contents, right? So to create a copy of an entire directory, we want to copy a directory recursively, meaning copy this directory and everything inside of it. There is a command in Unix to do that. Is cp, this is for copy, cp space, right? -r, that means copy recursively, everything that I say, right? Space, Turkey, capital T and tab, space, and space. Now we want to take Turkey and everything in it and copy it to something else. Call it something else. Let's call it Hogwarts, right? We'll just pick up some. Let's call it Hogwarts. 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 Yeah, enter. Yeah, enter. Now go into that directory, cd to Hogwarts, cd space Hogwarts,
cd
space Hogwarts. Yeah, enter. And do an ls-l here. You should see those 4 files. ls space -la, 4 files. You see the 4 files? Okay, now let's all change these files, right? So go to nouns.txt. Go to now. Oh, I see. How do you edit this? Type in Emacs and hit enter. Emacs. Say Emacs. EMAs. Oh, no, don't do Emacs. I got to walk you through the code. The control key is harder. No, the control key for Emacs is harder. How do we edit the file? You know what? Let's edit this in. Let's just edit it in Xcode. It'll be easier. Just go to your Xcode. Go to your Xcode. Go to your Xcode window. Yeah, it'll be easier. Xcode window. Is that your Xcode window? All right. Do you see that folder here that you created?
Folder I created?
No, it's
no.
Oh, you need to refresh the window. How do you refresh this whole thing here?
No.
And you. Well, how do you close the project and reopen it? Maybe it'll reload it. Close the project, reopen it. Yeah, reopen the project. Do you see that folder now? So
no.
Xcode is basically filtering it out. It's there, but Xcode is not showing it to you, the text file, because because it thinks it's not relevant to the project. We need to edit those files. Anyway, this is what I'm trying to do, or what I inside of the file. What we want to do is edit the nouns.txt file. Are you guys following? So actually, you just open that file and text edit, right? Close Xcode. Go back to that. Go back to the green thing that you had, right? Right. Okay. Right now, what we want to do is type text edit and hit enter. Text edit and hit enter. Text edit. Enter. I hope it's not in your path. Oh, it's not in your path. Okay. Here, just run text edit. Run text edit. Run text edit in Mac. Right. Just the no Mac command. Just run text edit Mac command. Are you guys okay on time? All right, run text edit on Mac. Just run Mac on your Mac. Just run the text edit command. Click the magnifying glass at the end or something like that, and run text edit. Click on the bar right in the top. You have to run text edit. There's a command called text edit. Just like you ran terminal, there you need to run text edit. How did you get that? I think it's command space. Hit command space. Hit command space. All right, now type text edit.
Text?
Yeah, edit. Enter. Mm-hmm. Okay, let's wait for it to fire up. Is all right. Now, no, not new document. What we want to do is where it says that drop-down menu text edit, click that. Click the drop-down menu. Yeah, there, click that. Where you want to go is go to, you need to go to your desktop. How do you go there? Why isn't the whole thing showing here in your text edit? Now go up to your the menu, the text edit menu at the top, and you need to navigate to your desktop folder where you stored those 4 files. Those 4 files. Yeah. Hang on. Click. Oh, you somehow went there. Where are the 4 files?
I think.
Click,
no.
No, on the left. I see, because your font. My fault. Actually, I should increase the size. I'm just, I can't see. All right. Oh, there you go. On the left. Click on the desk. Click on desktop on the left. You see on the left. Yeah. Click up, further up. Yeah. There you go. Now you'll see a folder. Random sentence. Click on random sentence. Click on random sentence. Okay. Click on that. Click on that. Click on that. Click on packs. Click on Hogwarts. Right. Now we want to edit. What is it? Nouns.txt. Click on nouns.txt. Click that. Yeah. Double click. Or open, whatever. Okay. Now, can you increase command plus a couple of times? All right. Now I increase the size of this window, and then Command A and delete everything. Command A, delete everything. Right. And now type in what I say. Type in who's the wise guy, the professor. The professor at Hogwarts. Dumbledore. Type in Dumbledore. 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 Type in Dumbledore. D-U. Oh, you haven't read Harry Potter?
I know the name, but I don't know how to spell his name.
Okay, Dumble, D-U-M-B-L-E. Door, D-O-R-E. All right, enter. Ginny, G-I-N-N-Y. G-I-N-N-Y.
Sorry.
Yeah, Ron. You know, the magic wand. Is there a name for the wand? Voldemort. No, Voldemort. And Hermione. Voldemort. V-O-L-D-E. V-O-L-D-E. M-A-M-O-R-T. M-O-R-T. V-M-O-R-T, yeah, okay. Come on, guys, I should not be the only one here, okay? Voldemort, and things, what about things? You know, what is that? Goblet, 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 and type in goblet. Come on, goblet, G-O-B-L-E-T. G-O-B-L-E-T.
I gotta get going.
L-E-T. Yeah, hey, what was that, Mark?
Sorry, I just gotta get going. Thanks for everything.
Oh, you gotta go. All right. Anyway, so you got to fill in some nouns here, and then verb. When the verbs file, you pick up some, you know, verbs from the Harry Potter series, like, you know, flew or casting a potion. I'm sure there are some verbs that are very unique to Harry Potter, right? Or you can put in some spell names, right? Some spell names here, and so on and so forth. So pick these up, and then you run your program saying, "Lucky Hogwarts." It'll print a sentence from the Harry Potter's universe. Does that make sense? Okay, now what we wanted to set out to do at the beginning of this class, but we actually didn't, was to write a new version of the display function, right? Display function, well, we don't have to do it today because most of you are leaving, I guess. We can do it some other time if you guys want. But essentially what the display function should do is take the sentence that's given to it. The basic function that we have now basically just does a cout, right, of that. But instead of doing a cout, what it should do is do something fancy. What I was thinking was print a whole bunch of random junk on screen, but use /r instead of /n, so it just keeps overwriting the same line instead of printing it on next line each other, right? So it'll print a junk line, lots and lots of junk lines, but it keeps printing junk lines, but at each time it prints a junk line, one more of those letters might settle to its final thing. So as you're looking at it, you'll see a whole bunch of sentences, letters shuffling, but as the letters are shuffling, one by one, those letters will start settling, right? And when they settle into the correct letters. So when everything is done, when everything is settled, you'll see the final finished sentence. We can actually do that. It'll only take like 5 or 10 minutes. If you guys are game, I'm happy to walk you through that right now. Otherwise, you can just take this on as your own homework, write a display function and share it with this on Reddit so that everybody can, you know, download it and play with it. Also share some instructions, right? You know, take this program, compile it and create your own pack this way and so on. Create some documentation. So there's some good practice for creating a functional program that is shareable with instructions for users to extend it, right? So very first one that you might have written, right? To create something that people can take, play, and extend to have it run with their own personalizations, their own packs. Yeah, it's a really fun little project that you can put together in less than 2 hours, right? Like a boot camp exercise, 2 or 3 hours.
So I've done some update to the function. Like if you update the function, should we do it like in Reddit and sharing stuff?
Yeah, totally. Share it on Reddit. And in fact, if you got a complete version with a good pack and all, I would be, you know, one of the most interested people to download it and try it myself, right? Because today I was kind of hoping that we'll get the display part of it done, but then I had to step away and all. And but was this useful anyway? We didn't cover any new ground today, but was this useful so far? What we did? Yeah. Great, thank you. So next week when you guys come back after the midterm, and we'll start talking about objects, right? Now C++ actually begins, right? Until now we've only done C, not C++. Now we're going to do real C++ after the midterm. Yeah, and feel free to just ping me or let me know, or if you have any questions, send me email. Make use of the STEM Center before the midterm and before the final. They actually run extra hours, and it's like open 24 hours with extra tutors and all. So make use of these things, right? The division actually pays for all these things, and we hope that every student has a fulfilling experience, right? At the end of the day. That's the mission of Foothill College anyway, right? All community colleges. All right, great. I'm so glad we actually managed to get something done. Everybody okay so far? Chanyi, Turkey, Isaiah, you haven't spoken and your camera is off, so I want to make sure that you're good. Are you good, Isaiah? All right, someone reach out to him and ask him to reply to my email also. Well, I guess I hope he's good, right? You all should be just moving along in your questioning and the material for C++. All right, great stuff, great stuff. I had a great time. Thank you for humoring me and being patient. I'll see you guys on Tuesday. Have a good weekend, okay?
Thank you, Professor. Bye. And Professor, I finished my quest 4.
Yeah, I'll import it on Monday. Don't worry, okay?
Okay.
Even before the final, you can remind me if I forget.
Okay. Thank you. Have a good weekend.
You too.
Thank you.